Part A. For a steady flow of non-viscous incompressible fluid, the Bernoulli's equation can be written as P plus half rho V squared plus H rho G equals constant. Here all symbols having their usual meaning. Identify the terms of the left-hand side of the equation. We have to write terms. P is pressure. Half rho V squared is the kinetic energy per unit volume. H rho G is the potential energy per unit volume. You have to write only these three terms because of when identifying terms of an equation, we have to consider there are only three terms in the left hand side. P, rho, V, H are not terms. Terms are P, half rho V squared is the second term, H rho G is the third term. Then B, a racing car having a rear spoiler with a curved surface at the bottom is shown in the figure. According to the Bernoulli's principle, when the car is moving at a high speed, a downward force acts on the spoiler. A vertical cross-section of rear spoiler of the racing car moving horizontally through air towards the left with constant velocity v relative to the ground is shown in figure 2. Part 1. What is the velocity of air at point x relative to the car? Assume that the air is at rest relative to the ground. Now they have given a figure of cross-section of the spoiler like this, and x is a point inside the car. We have to find velocity of air at point x relative to the car. Now car has a velocity v to this direction. When considering velocity of air relative to car, we have to consider relative motion of air relative to car. It means we have to consider that the car is at rest. To make at rest, we have to give v velocity to the car and same velocity to the air molecule. Now velocity of air molecule relative to car is v to this direction. Direction is compulsory. Or we can decide directly when car is moving right hand side, air medium is moving opposite to the same magnitude of speed. Then part 2, as shown in figure 2, the cross-sectional area of an imaginary flow tube away from the spoiler is A1 and the corresponding cross-sectional area same flow tube below the spoiler is A2. If A1 divided by A2 is 1.2, they have given a flow tube like this. When considering this point, area A1, then considering this point, area A2, and they have given A1 over A2 ratio is 1.2. Write down an expression for the speed V2, air relative to the car, flowing under the spoiler in terms of V. Now we can consider velocity at this point is V. We have to get velocity at this point V2. And if it is a steady flow, we can use equation of continuity. A1 V1 equals A2 V2. A1 divided by A2, I will subject A1 divided by A2 equals V2 divided by V1. A1 over A2 ratio is 1.2. We have to find V2. V1 is given as V. Then I will bring V to the left hand side. 1.2V equals V2. It is the answer for part 2. Then part 3 is the effective cross-sectional area. Effective horizontal cross-sectional area of the spoiler is 0.2. Effective cross-sectional area 0.2. Calculate the downward force acting on the spoiler. V 360 kilometers per hour and density of air 1.2. Effective cross-sectional area means cross-sectional area of this part. It is given as 0.2 square meters. Now, there is a pressure change between this point and this point. We can consider this point is like this one because of due to this shape, velocity of this place is not changing relative to car. It is V. Therefore, there is the same velocity in this line, V velocity, and same velocity for this point. Therefore, we can use pressure difference between this point and this point should be equal to pressure difference between this point and this point. Then we can consider if this point is M and this point is N. This M point is like this point. And we have to use Bernoulli's equation to find the pressure difference. Now I will write Bernoulli's equation between M and N. Part 3. P plus half rho V squared plus H rho G for point M should be equals to P plus half rho V squared plus H rho G for point Q. Sorry, point M. Now, when considering height difference for M point and N point, we have to consider it as a negligible value. It is not given in the question, and we know that it is a small value, upper and down sides of spoiler. Therefore, we can cancel out H rho G. We can consider this line. This line is a horizontal line. And I will consider pressure at M PM plus velocity at M V. Then we can substitute half rho V squared. Pressure at N Pn half rho. Velocity at N is V2. Now we know that V2 has a higher velocity. We have found it 1.2V. V2 has a higher velocity. Therefore, this term is greater than this term. I will bring this part to the right hand side. Then Pm minus Pn equals half rho V2 squared minus V1 V squared. I have obtained factors, common factor half rho. Now we can substitute Pm minus Pn, pressure difference, half. Density of air is given as 1.2. Now we can substitute V2 as 1.2V. We have obtained previous part, 1.2V squared minus V squared. Now we have to simplify. 2 divided by 2, 1, 0.6. 0.6 into, there is a difference between two square terms. We can simplify easily. We have to consider sum, 1.2V plus V, 2.2V. 1.2V minus V, 0.2V. It is the pressure difference, Pm minus Pa. Now I will substitute V value. We can multiply 6 into 2, 12, 12 into 2, 24, 2 remaining, 12 into 2, 24 plus 2, 26, 1, 2, 3, there are 3 decimal places, V squared. Now, V value is given, velocity of air relative to car is 360 kilometers per hour, 360 kilometers per hour. We have to convert it to meters per second before substituting value. I will convert kilometers per hour to meters per second. 360 kilometers per hour. Kilometers divided by 1 hour. Now we can convert kilometers. We have to multiply by 1000 to convert meters. 1 hour, 3600 seconds. We have to convert kilometers to meters and hours to seconds. Then we can cancel out 2 zeros. 100 meters per second. Now we can substitute V value 100 square. 0.24264 into 100 square. Then answer is we have to bring decimal point 4 times to the right hand side. Pascal or square Newton per square meter. 2640 Pascal or Newton per square meter. Now it is the pressure difference. We have to calculate force. When calculating force, we can use pressure equals force divided by area. Now force is pressure into area. Pressure is 2640 into effective cross-sectional area. Effective horizontal area of the spoiler is 0.2. We can multiply it. 2 into 0, 0, 2 into 4, 8, 2 into 6, 12, 1 remaining, 2 into 2, 4 plus 1, 5. And we have to separate 1 decimal place. 528 Newton. Then part 4. If a wind is blowing horizontally relative to the ground from left to right with constant velocity, will the force calculated in part B3 above increase or decrease? Give reasons to your answer without any calculation. When using the car, the force is depending on the relative motion. The motion of air medium relative to car. For the given situation, wind is blowing horizontally from left to right. Car is moving from right to left. There is a wind from left to right. Therefore, there is a wind in opposite direction. Therefore, relative velocity increases, and because of the calculated force will increase. Then we have to write force will increase because of the relative motion of air relative to car increases. The relative velocity increases. Then part 3. When the car moves in a high speed, the drag force Fd acting on the car due to air is given by Fd equals half C rho AV square. Here C is known as the drag coefficient, rho is the density of air, A is the effective frontal area of the car facing air, and V is the speed of car relative to the air. Spoilers also changes the direction of airflow on vehicles and reduce the drag coefficient. Part 1. So that C is dimensionless. Now that equation is not an equation in the syllabus, but it is easy to calculate. Drag force is given as half C rho AV square. We have to consider dimensions. I will use dimension of force MLT minus 2. Half is a constant value. There is no dimension. We have to find dimensions of C. Rho is density. Dimension of density ML minus 3. A is an area, L squared, V is velocity, LT minus 1 squared. Now we have to subject T. We can cancel out M. L T minus 2 equals dimensions of T multiplied by, then simplifying these two terms, L minus 1 multiplied by, I will get the square, L squared T minus 2. We can cancel out T minus 2 and L divided by product of these terms, L divided by L, it means 1. Therefore, C has no dimension. C has no dimension. Then part 2. Taking C 0.3, A 1.4, rho 1.2 and V 360 kilometers power. Calculate the drag force SD acting on the racing car mentioned in part B above. Assume that the air is at rest relative to the ground. Now we have to substitute values for given equation. It is easy. Now you can identify if there is an equation or theory in the question which is not in the syllabus. It is easy to simplify. Then FD, we have to find that force half into C value is given as 0.3. Rho is the density. Density is given in question 1.2. Area 1.4. It means phased area of the car. V squared, we have found V value is given as 360 kilometers power. We know that it is 100 meters per second squared. We can cancel out 0.6, 6 into 3, 18, 18 into 14, 0.8, 32, 3 remaining, 4 into 1, 4 plus 3, 7, 1 into 8, 8, 1 into 1, 1, 2, 15, 1 remaining, 1 plus 1, 2, 2, 5, 2, 1, 2, 3, there are 3 decimal places, multiplied by 10 to the power 4, 2520 Newton. It is the drag force acting on the car. Calculate the power needed to overcome the drag force when the car is moving at a constant velocity 360 kilometers per hour. We know that drag force is a type of resistive force. It is like friction. And we know that when doing a work done against the friction, power is frictional force into velocity. We can obtain it by using, we know that work done is force into distance. When considering a resistive force, friction or like drag force like this, work done against the friction is force into moving distance, frictional force into moving distance. Then we can divide both sides by t. Work done divided by time is power, drag force into velocity. We have to calculate power. Drag force is 2520. We have to multiply by velocity. Velocity is 100 meters per second. We have to substitute in meters per second. Then we can give the answer 2520. There are 2 zeros. Watt. We can write it 252 kilowatt. It is not compulsory. If you are giving answer in watt, it is sufficient for the part 3. In part 4, the car starts from rest and achieves a speed of 360 kilometers per hour. A student argues that the average power needed to overcome air drag in this process is P over 2. Where P is value calculated C3 above. Given reasons state whether you can agree with the argument of the student. We can substitute F value, F force by using given equation. Then I will use power equals to force into velocity, that force into velocity. Now I will use the equation for that force, half C rho AV squared into E. Now we can see power is directly proportional to cube of velocity. If there is a linear variation, this argument is correct. We can get initial power 0 and final power this value, and we can divide by 2. We have to get sum of initial and final powers and divide by 2 if there is a linear variation. It means if power is directly proportional to velocity, but now power is not directly proportional to velocity. Therefore, we can't get that power of the given situation is the mean power. Now we can write power is not varying. Power is not varying linearly, therefore do not agree. For the statement, the given statement is not true. Argument is not true. So part 5, this is part 4. The power needed to overcome the frictional forces acting on the car, 48 kilowatt. The energy released by burning 1 liter of petrol is 4 into 10 to the power 7, and only 15% of energy is used to move the car. When the car is traveling at constant speed 360 kilometers per hour, determine the fuel efficiency of the car in kilometers per liter. Now, we know that the car is getting 10 seconds to move 1 kilometer. 10 seconds to move 1 kilometer. Then I will calculate power consumption for 1 kilometer. Against that force, 252 kilowatt per second. Kilowatt value means energy per second. Plus 48. It is the 48 kilowatt, 48,000 watt. It is the power used against the friction. That force means friction due to air. Friction means friction due to earth, the motion between earth and tires. This is the total power needed to move with a constant velocity. It is moving with a constant velocity. Therefore, there is no any work done to increase velocity. And we have to consider the road is a flat road. Therefore, there is no an energy consumption to increase the potential energy. Then we can consider this is the work done per second. Now I have considered movement of 1 kilometer. When considering movement of 1 kilometer, we know that it is moving with 100 meters per second. 100 meters per second. Then 1000 meters per 10 seconds. Then we have to multiply by 10 to get the work done for 1 kilometer. It should be equals to when burning 1 liter of fuel, it will release 4 into 10 to the power 7 joule but in the car using 15% of energy effectively. 15%. It is for 1 liter. I will consider we have to use n liters per 1 kilometer. Now we can find number of liters per 1 kilometer. But we have to give the opposite answer. Before finding it, I will simplify it. We can cancel out 2 zeros, 10 to the power 5, and again 1 zero with this 10. We have to add these values. 2 plus 8, 10, 1 remaining, 5 plus 1, 6, plus 4, 10, 1 remaining, 3. Divide by 4 into 10 to the power 4 into 15. 1, 2, 3, 4. Divide by 15, 2, 1. 2 divide by 2, 1, 2. Then half liters per kilometer. We have to find number of kilometers per liter. Then it will get half liters to move 1 kilometer. Then we can multiply by 2. 1 liter for 2 kilometers. Therefore, we can write petrol efficiency or fuel efficiency 2 kilometers per liter. Then part 6. If wind is belonging to horizontally relative to the ground from the left to right with a constant velocity of 10 meters per second, calculate power P dash needed to overcome the drag force when the car is traveling of constant velocity 360. Give your answer to the nearest integer in kilowatt. When considering the situation in part 6, there is a velocity left to right. Left to right means opposite to the movement of car. Therefore, relative velocity of car relative to air, we can consider 110 meters per second. There are opposite velocities. When considering car and air medium, if there are opposite velocities, we can add, or we can use basic theory to find the velocity. Then we can find power. Power equals to force into velocity. We can substitute the given equation for drag force, half C rho a v squared into v. And we have to substitute values. Half C is given in the question 0.3, density 1.2, area, face area 1.4, velocity is 100, 110, relative velocity of air 110 into, but we have to consider one situation. For this part, when substituting v velocity, we have to use this velocity is the velocity of car. It is not relative velocity. Drag force is depending with relative velocity. Therefore, we have to substitute relative velocity for drag force 110 square. But when calculating power, power is force into distance. Distance means the distance traveled by the car. Then when dividing both sides, we can get distance divided by time is velocity. Therefore, this velocity is velocity of car. It is not 110, it is 100. And we can simplify it. Approximately we can get 305 kilowatt. Now we can understand if there is a wind against the motion, the drag force will increase and due to increasement of drag force, there is a more power consumption. It means if there is a wind against the car, this value, efficiency, number of kilometers per liter should decrease. Therefore, fuel efficiency of a vehicle is depending a lot of things, not only engine and vehicle condition. We have to consider condition of road, condition of wind,